Um, just a very quick introduction from myself. I'm Chris Given, Strategic Bid Manager here at EA Technology. I work with our Insights business, where we support businesses with strategic decision making through a range of consultancy and software solutions. We also have Joanne Peacock, who will be delivering the session today. Joanne heads up our asset investment management team and has a wealth of experience delivering asset health and risk-based modelling and support solutions. It's really good to have so many turn up for the session today. If you're new to this series, this actually represents the fifth presentation in a series we've been pulling together, where we've been looking at a range of topics to do with asset health and risk modelling. So the agenda for this session, we will be, first of all, providing a quick recap on asset health, probability of failure and risk. We'll be looking at failure modes and defining asset failures. We'll be looking at how we go about calculating probability of failure and how this is calibrated to reflect known failure rates. We'll look at some of the common challenges when considering probability of failure. We'll look at some of the key data points when capturing fault and failure data. We'll look to draw together some conclusions from the session and open up opportunity for questions and answers at that point too. We'll be also looking ahead at future webinars. As I mentioned, this is the fifth in the series now, so we'll be inviting suggestions for future topics also. We anticipate around about 45 minutes for the presentation itself, leaving plenty of opportunity for Q&A. And Joanna, I'm sure if there's questions that come in through the chat, as they often do, we can maybe pick them up as we go along also. So feel free to pop questions into the chat. So all things said, if that's okay, I'll pass across to Joanne now and she'll be taking us through the session. Thanks very much.
You're ready. Yeah, apologies if we're heading through the session and I don't capture something which is on there, and that's why Chris, one of the many reasons Chris is here, but he will pick up on those things and yeah, make sure that we answer all your questions before the end of the session. Right, okay, so a bit of scene setting to get us underway. If you've been to our previous webinars, then you've probably seen one or two of these slides before, but this will be a little bit of a recap on that. So just setting the scene really, asset health, probability of failure and risk. What do we mean by these things and how are they linked together? So asset health, very simply, is a measure of the asset condition, and we use a scale of 0.5 all the way to 10 in the current year, and 10 is a poor asset health and a 0.5 is an asset which is new, and we can broadly grade these and say that they're sort of good, fair, poor and bad. And then we generally have a management strategy for dealing with these different types of asset health bands. So we've got new condition, routine maintenance, intervention required, or at end of life. And obviously this is a little bit subjective and it depends on where you are within your organisation and how the appetite for risk might differ, and how the stakeholders involved in your organisation might also have an input into the risk or the perceived risk of asset failure. So that's asset health in a very, very quick nutshell. We relate asset health to probability of failure, and we can measure that on a graph like this. So we have the asset health, which is down at the bottom, and that goes from our scale of 0 to 10. And then we have probability of failure, which increases as the asset health also increases. And we have this generic shape of an asset probability of failure curve. I think it's that way for you. Yeah, so we've got this sort of flat bottom to the curve, and and this sort of exponential sort of increasing part of our failure curve. And so we can again start to put some of the definitions onto this. So in this sort of green zone, we've got this measurable deterioration, but no significant increase in probability of failure. And then as we move into the orange, we can see there is more significant deterioration with small increases in probability of failure. And then as we move to sort of a health score, asset health of 10, we can see serious degradation and significant increases in probability of failure. So that's how the two interrelate, and they've got a relationship clearly. The higher the health, the higher the probability of failure. When we move on to risk and criticality, the way that we calculate that, so that's both in our own methodology called CBRM, or condition-based risk management, and also CNAME, which is the common methodology that I've talked about in previous webinars. And I will mention and pick up on CNAME because it's a great reference. I've mentioned it previously lots and lots of times, and it's our baseline reference. So it's the reference that the GB network operators, distribution network operators, must record and report their assets against, common methodology, or CNAME for short. And so it's a really convenient place where you can look at the public documents and you can see exactly how some of these things unfold. That particular document is designed for use within Great Britain, and I know none of you on the call are actually in the UK at the minute, but it's a useful reference anyway. And we've seen companies in different places, so Canada, the States, and Australia and New Zealand, picking up that methodology and starting to use that. So if you are starting to use common methodology or something similar, then hopefully this presentation will give you some confidence in where probability of failure came from, and also how to manipulate the inputs in probability of failure to sort of suit your own operating environments. And from that, you'll understand that a key part of probability of failure is then moving towards risk. But to get to risk, we also need to get to consequences of failure. And so we very simply define consequences as the criticality factor. So this is how important an asset is, times an average consequence. And so the way the methodologies work, we define an average consequence for an asset type or an asset fleet. And then we look at how important each individual asset is, and we multiply the two together to get a sort of a guide in terms of the consequences of failure, and this is measured in monetary terms. And this relates to probability of failure. We multiply it by probability of failure, and then we get risk, and that's what we say is the risk of failure of a particular asset. So probability of failure, therefore, it's pretty important in terms of the asset modelling. It's the thing that hangs together the health and the consequences of failure, and it makes risk, essentially. So I've really talked about sort of these aspects that are on the screen at the minute, but essentially what we're trying to do is create a probability of failure and that relationship with health. And if you can do that for the current year, there are also algorithms both in common methodology and our own, which incidentally the same, that will enable you to age the asset population forward, so age the health score forward. And if you can age the assets forward, you can then use the established relationship between asset health and probability of failure to create a new probability of failure in the future. And when you sum up the probabilities of failure, you get the failure rate. So you can see what the failure rate is now and also what the failure rate is in the future. And then going beyond that, you can start to look at what happens if you intervene on particular assets, so replacements, refurbishments, and potentially some maintenance or reconfigurations. And you can see what the effect is on the probability of failure. And then you can also see the effect on the risk. So how much risk have we removed from the network or from the environment by doing particular interventions? So it's the thing that holds everything together. So really critically important. So that's a bit of the scene setting. Now we'll start looking at what we call failure modes. So asset failures, we don't just class the catastrophic failures as a failure. It's useful to look at the catastrophic failures, but they happen so rarely and so infrequently that it's also useful to look at other different types of failure. And so it's useful to put a definition on what we mean by failure. And I've tried to do that on this slide by saying that a failure is an event that results in an asset being unable to adequately perform its intended function. So these are often interruptions to supply or failure to produce its production failures and things like that. But they can occur in a range of sort of criteria. So they can be electrical failures, they can be mechanical failures, they can be operational, safety, or environmental failures. There may be other sort of slight distinctions there, but those are the main ones that we tend to look at in terms of the different types of failures. And then we also want to subcategorize the failures into what is a condition failure. So these are related to asset degradation, and those are the things that we can do something about. And then you've also got potentially non-condition failures. So this is things like, as we've got there, so we've got third-party damage or willful damage, wildlife and weather incidents. So that could be things, it could also be things like bushfires that go in those kind of categories, lightning, all sorts of things that you can't really predict or do anything about. And so because we're relating the probability of failure to the asset condition, what we really want to be concentrating on is those condition-related failures. And so when we start to define failure modes, we start looking at what the failure types are and what are the outcomes of those failures. And so we use up to 5 failure modes depending on the asset type. Common methodology uses 3 failure modes, which I think I've got on the next slide. But it doesn't matter how many failure modes you've got, you just need to define those. And it's really useful to be able to define them in terms of the severity, because it's much easier when you start thinking about the consequences of failure. It's much easier to think of what happens if it's a catastrophic failure, what's the impact of that, or what happens if it's a minor failure, what's the impact of that, so both monetary and supply wise and to the environment, etc. So we're looking at the failure modes in relation to their broadly in relation to their effects. And so we go through a bit of a process which is similar to FMEA, in terms of looking at failure modes for the different types of assets, what can happen, what are the effects of those things happening, and also how we can prevent those things from happening. There are a number of different approaches that you can take in terms of the modelling. The way that we do it in CBRM is slightly different from common methodology. And so because we've just got some slight differences, I put them on at the slide. And it doesn't really, like I say, it doesn't really matter how you chunk them up. It's more about what sort of level of granularity you need at the different reporting levels. So I appreciate that if you're using a full FMEA, that can get quite complicated quite quickly. But if we just concentrate on sort of 3 or 4 or even 5 failure modes, it can actually be implemented quite simplistically. So the CBRM approach takes the failure modes and it defines them into 3 or 5, up to 5 categories, and then we define a failure rate for each of those failure modes based on data that we collected or determined, and then from there we can start looking at the consequences per failure mode. Common methodology is slightly different, takes a slightly chunkier approach to it, and it basically has a current failure rate, and you proportion the failures by the different types, so by the different failure modes. So it's not quite as transparent the way that's done, but that's considered adequate for the purpose of what it's trying to achieve. So like I say, there's different approaches there. And so, as I mentioned, failure modes are defined in terms of their outcome or severity. And so in common methodology, we've got a really useful definition of what the different failure modes are. So incipient is a minor failure associated with early stage degradation. Degraded is a significant failure associated with advanced degradation, and catastrophic is a sudden and total loss from which recovery of the asset is not possible or feasible. And so it's really useful, no matter what failure modes you're choosing, but to have some of these descriptions. And then we can go one step further for the different asset types by saying, well, what kinds of failure are we talking about for incipient and degraded and catastrophic? And again, this is taken from the common methodology documentation for switchgear, and we can see things like stuck breaker, failure to trip. Those are kind of incipient failures, and then degraded failures, low gas lockout, and then you've got your catastrophic failures, which are your loss of your asset. And then again, just for some guidance in common, we've got that incipient is up to 10% of the asset value as a general proportion. Degraded is up to 25%, and then catastrophic is over 25%. And what they've done in common is they've applied that same rule pretty much to every asset class. So whether it's almost a high voltage transformer, or whether that's just a pole, they've applied these same kind of proportions and rules. And that's really useful because we're starting to look at quite a common currency between the asset classes then. And we know what everything means and what proportionality we're looking at. So now we'll move on and look at calculating the probability of failure. So the way that we calculate this is based on this sort of John Mowbray's reliability centered maintenance. And within that, there are 6 definitions. There's basically 6 sort of curves that we can use to proportion our probabilities, our failures out. And obviously, a lot of people have heard of sort of the bathtub curve, where you get that sort of initial hit of installation and issues and sort of parts and things that aren't quite working. So we do get a proportion of failures at the beginning of the asset life, and then towards the end of the asset life we get this wear out. And if you've seen the sort of Weibull distributions, you get the middle bit of it, which is generally the sort of in-service period. And so what we've tried to do in our asset modelling, which has been adopted by the common methodology, is we've tried to look at these curves and try and choose a single curve that fits basically all these purposes. And what we found is that curve generally is similar to the one that's presented on the right of the screen, and that is when time increases in probability of failure. You've got on the y-axis that you've got a flat, relatively flat bottom to the curve, and then it starts increasing at quite a rate. And we've applied that type of curve to millions of assets, and we found it sort of meets the requirements or the needs of our customers in terms of they agree it's sort of the best fit for electrical assets and assets in general. So we don't generally see, and this might be different in your experience, but we don't generally see a high level of infant mortality. It tends to be relatively low, and you get these occasional random failures before you're sort of starting to get to kind of wear out periods. But essentially this is the sort of reference that our failure curve comes from. And so we did a lot of research, we started building health indices way back in sort of around about 2000, and we started looking at asset health and developing that. And then a bit later on, around about 2002-3, came probability of failure. And we started working with a sort of an exponential type approach, and we applied that. But when we applied that to real assets, we found that the rate of degradation at higher values of the asset health were significantly higher than our customers were experiencing in practice. So that led us to take on a bit more mathematical modelling, and we did some studies with some universities to look at different types of curve that might fit the distribution that we were seeing within our customers a bit better. And so what we came up with is a cubic equation, and this cubic equation worked reasonably well, higher health index assets, but at the low end, again, that didn't sort of match experience. And this is where we start to modify the curve again. So we have this now, this cubic, but this modified cubic, and the modified cubic is the flat bottom to the curve before we start increasing using that sort of cubic equation. And we can start to see what that looks like actually as a formula written down. So on screen, we've got the formula for the modified cubic equation. And we've actually got sort of two versions of it. So the first version on the left-hand side is for a health index of greater than equal to what we call HI lin. And so HI lin is a constant, and we set that as the basis for the flat bottom of the curve. And we nearly always set that to be a value of 4. So we're saying that for all asset health, for a value of 4, we're going to calculate the cubic part. But for assets that are less than 4, less than HI lin, we're going to use this equation on the right hand side, and we're going to use HI lin in place of the asset health. The other parts that go into here are C and K. And so C is a constant, and C sets the shape of the curve, and K relates to the failure rate, the failure rate. And we can again see how they look. So the way that we apply this is almost in 2 bits. So if we take everything in brackets, that's what we refer to as the relative probability of failure. And so if we take our asset health for any given population, and we spread those out over this shape of the curve that we have defined, you get something like what we see on screen. So we've calculated our health indices, and then if we put in our known overall probability of failure, we then use the K value to match the assets up to that level. And in doing so, we then get the correct probability of failure for those assets. And as I mentioned, if you sum up the probabilities of failure, you get the failure rate. And I will explain that in a little bit more detail, because it's some people have seen common methodology and they see this value of K and think it's a little bit mysterious, but it relates to the failure rate, and I'll show you how that happens. It doesn't, because the common methodology is designed to tell you what to do. It's not designed as a book that's going to explain to other network operators or industrial customers or other utilities. If you pick it up, some things don't always make sense because, you know, it's designed to tell you what to do, not how to do it. So the calculation of K is pretty critical because it relates to the failure rate, and it doesn't tell you how to do it. So I'm going to give that a bit of a go. So what I've got on screen is a population, just 15 assets. And then in the first column, we've got the current health score. And then to make our calculations just a little bit easier, I've got the health score for calculating the relative probability of failure. And so what I've done here is set our flat bottom of the curve to be a maximum, to be a value of 4. So every asset that is less than 4, I've given it a value of 4. And every asset that's over 4 takes its original value. And from there, we can add in the relative probabilities of failure, and that's applying that cubic equation, but without that K multiplier. So if for our population, the average numbers of failure per annum is 5, and we usually take an average number of maybe the last 5 years as our failure number of failures. And if we assume C is 1.087, which is, again, it's a standard value, and I'll explain a bit more about that shortly, then the average number of failures per annum is K times the sum of the relative probabilities of failure. So that's what you get in common methodology document. So the relative probability of failure is the bit in brackets without sum, and therefore K must be the average number of failures per annum over this sum of the relative probabilities of failure. So what we've done here is, if you look at this column, we've summed up the relative probabilities of failure there. And if we take the average numbers of failures per annum and we divide the relative probability of failure by that, then you get the value of K. So we can test that because we can then take each of these numbers and multiply them by this 0.0038, and we will get our probability of failure. And again, we can test that's right because we can sum all of those up and they equal 5, which is the number that we started with in the first place. So it's quite straightforward to calculate K. It's just a common methodology doesn't tell you how to do it. So if you're using something like common, using that as a reference, you can obviously use the slides and work out how to create the failure rates for your population that relate to you. So more calibration then for the probability of failure. So we talked a bit about K. Now we need to set the value of C. So C is the slope of the curve, our probability of failure curve. And if we didn't have a flat bottom to the curve and we're just using these values as they are, then you can see how different values of C will give us these different shapes. When we have got a flat bottom to the curve, you can see how the shape changes, and you can see the relative ratios between assets at a high health index and assets at a very low health index. And so the value that we tend to use, and the value that's in common methodology, is 1.087, and this gives us a really nice ratio of 10 assets will fail at a high health index of 10, compared to 1 on the flat bottom of the curve. And that relationship tends to be the one that's accepted as normal for the experience, certainly in GB in the UK. So that's what we stick with for everything. I wouldn't say that's absolutely universal, and obviously you can play around with those different shapes of the curve to see whether they match your experience or not. But it's a good starting place. So if you're new to asset modelling, there's clearly some challenges that you might have. So the first challenge that we see quite a lot in customers. So this is customers who are new to asset health, or this is customers that are new to modelling a particular fleet, is that they don't have a health index. And so if you don't have a health index, it's really hard to produce probability of failure and then risk as a result of that. So this is a little bit of a process in terms of how you would go about doing that. So if you're just starting on your journey, you might just have a asset profile that looks something like the one on the left. So this is an age-based asset profile, and this is on the basis that assets will not accelerate past a value of 5.5, so 5 to 6 category, unless they have some specific condition information. And that's a criteria that we set within our models for most asset classes. It can vary a little bit, where there are assets where it's just not feasible to get asset condition information, so we may allow that cap to be removed. But for most sort of significant assets, so switchgear, transformers, towers and things like that, then we cap it and say, actually, without that specific data to say that the asset is in poor condition, you can't condemn that asset on the basis of age alone, or even age and location. And so we have a bit of a hard stop there, and we don't have huge variability of results, but at least it's a start. By the time you go out and start collecting data, you might end up with a profile more similar to the one on the right hand side. And this is where we do see a proportion, even relatively small proportion of assets in those in poor condition. And so we can start to address those and do something with them. And not only that, but we also find that the assets at the lower health scores, they just become more granular, and we're just much more confident in the results that they are producing. And so when we set the value of K, it can be quite tricky, and it can take quite a long time, even several years, to collect the data and validate the value of K. So in the interim, so a couple of options is that you go on calibrating values of K. You look at your types of failure, you doing that analysis, and you're doing that quite regularly, so it's ongoing calibration. Or you can just start from something like common methodology or a different reference point, and that allows you to sort of benchmark against what others are doing. So that can also be a useful starting point. But we know, obviously, calculating asset health and getting the data is not easy. It's not just going out and collecting it. It's a whole system of management and storage and all the rest of it. So that needs to take, that will obviously take some considerable time. But we've put this sort of circle together just to show you the different steps on the way. So you can start anywhere, collecting data, produce your asset health, create a reference failure rate, calibrate your asset health versus probability of failure relationship, compare results of asset modelling to experience. And that's the really critical bit, is that your asset health will differ slightly from others, because your environments are different, and some companies we go to have more issues with things like the environment, whereas other companies we go to, most of their assets are in nice air-conditioned substations. Some populations are much older than others, and they have their different challenges. And so it's really important that validation step, that you actually sit down with your asset engineers and say, do these results make sense? Is this what we're seeing in the real world? And that's highly critical. And then the second challenge might be that you don't have any historic failure rates, because you don't have that many failures. And again, we see this quite a lot, especially in sort of more transmission, can be distribution as well, but a lot in transmission, where the assets are just inherently reliable and they're designed to last, 40, 50, 60 years. So they're almost fit and forget type assets, some of them. So we do find that there are large numbers of failures happening, which is a good thing. And quite often they're getting to the assets, replacing them before we see the failures. So we don't know the true failure rate. But there are things that we can call upon to look at failures. So examples are industry-wide forums and things. So NAFA's, the bottom one, is one that we have here in the UK. But there are other studies and databases that you can access and potentially get hold of. And failing that, I've put a list of all sorts of different references on here. So we put the common methodology one, CNAME at the top, but there's all sorts of white papers and IEC documents, IEEE Gold Book. So there's quite a lot of material out there that you can use to start looking at different failure rates. And the bottom two, or actually the bottom three, are from network operators themselves. So the UK is especially good for publishing data, and Australia is quite good as well. So the two sort of regulatory websites, Ofgem and the ENA in Australia, they're really good resources, and there's a sort of culture of sharing information, so they're good places to head to for any of this kind of stuff. A third option for looking at failure rates is just really to look at what failures you've actually had, or what assets you're taking out of service. And so if you had an asset population, as the example here, of 1,000 and you made 32 replacements, then you can infer a failure rate as a result of that. And that's not just for catastrophic or major failures. You could also do that for looking at what kinds of repairs you're doing and how often you're going to see the assets, but then taking the opportunities while you're doing that to record that failure data. So that brings us on to capturing failure and fault data. So on this screen, we've got the generic shape of the methodology that we use. It's quite similar to common methodology. And so there's a couple of places where you can input the failure rate and failure type information. So entry points generally, so we have some direct entries. So if you know that a particular asset is failing and the asset will continue, that has an impact on that asset's lifespan or the condition of that asset, then we can use data directly. And then if not, we can use the failure information indirectly, and that comes in the probability of failure up here. And so direct measures are really where previous faults are indicators of future faults. And good examples of this, so examples and C name of this are oil of the different cable types. So solid cables, we're looking at things like fault history. And then for oil and gas cables, we're looking at leakage. So leakage information. So if an asset's leaking, it's going to continue leaking unless you do something more significant with that asset. So you can bring in that failure data and use that. And then sort of the indirect one, so this is not attributed to specific data, but this is the overall. You would use that to define your failure rates, and you would apply those to your asset populations. And again, you would do your failure rates and you'd look at the different severities or failure modes that they would sit under, and you would proportion those appropriately. And so just looking at, it's not an exhaustive list, but it's certainly a suggestion of the data that you would collect for each failure. And there might be other reasons for collecting other data. But first off, we've got a corporate identifier. So this is really just so that you can link the asset data with other types of data, and you can recognise where you might have problems within specific cohorts of data. So that might be particular manufacturers, particular vintage years or voltages or equipment types and things. So you would want to collect that. You'd also want to collect the date and time of the faults, so when it occurred, so that you can do your rates, your failure rates. You want to look at the causes of each type of failure, so that you know whether they're condition-based failure or a non-condition-based failure, and then obviously categorise those accordingly. And then for the consequence parts of the methodology, if you're using methodology similar to this one that has consequences for financial, safety, environment, and so for network performance, you'll want to collect things like the outage data. So how long the asset was unavailable for, and how many customers were affected by that particular outage. How long did it take to restore the power to those customers? And that might be at a staggered level. So you might be able to do something by switching or immediate remediation, and then a fix might take a bit longer to happen. And then we've got restoration costs. So those would go into the financial consequences of failure. So we would look at how much did it cost to repair the asset or replace the asset. And then safety and environment are things like, so safety is injury to people. So if you've got assets which are more in a more densely populated, was there an injury or a safety incident to those people? And then for environment, you're looking at things like loss of oil, loss of SF6 into the environment, disruption, costs to remove waste, those kinds of things would come under environment. And so you can use all of these things, you can use to then refine and improve the calibration that sits within the modelling. And so just moving on, just to conclude, so just a summary of what we've looked at. So probability of failure is key. It's key for understanding failure rates, both now and in the future, and it's essential for moving to risk-based modelling. It's got various constants that sit within it, and they need to be fitted to the circumstances. So failure rates, C-value, the shape of the curve, and potentially that HI-lim value, which is that flat bottom of the curve. And you need, hopefully now you've got an appreciation of what those little bits actually are and what they do. We've also talked about how CNAME and CBRM have its roots in things like RCM and FMEA, and the approaches are complementary. We've looked at some of the challenges that you've got starting a new asset class or starting to do some modelling, asset modelling, and finally we've looked at data collection, which is essential for improving the accuracy and helping refine the process going forward. So I think we're open the discussion up for questions.
I can pick up a few questions just that have been posted in the chat. The first one, Charles, I'm surprised that the definition of degraded included failure to operate. I would have expected this to be one of the catastrophic failure modes. Have I understood this correctly? I think that was associated with one of the earlier slides.
It was, yes. I mean, those are the common methodology failure modes. So it depends really on whether that involves the loss of the asset. So normally, if I think that was in a switchgear example, so failure to operate, failure to trip, then that would be classed as degraded, potentially in the UK. But this is why it's quite important for you to put your own definitions and to define what makes sense to each organisation, really, so that you've got a really clear understanding of what you mean by degraded failure and everything. So if it's in degraded, that's considered up to 25% of the asset value to remediate, and in the UK we definitely would do something with that asset, and we wouldn't replace the asset on that basis.
Okay, thanks for the question, Charles. Next question from Vadim. How was the current health score obtained?
Oh,
that's a question.
That's a whole nother webinar.
Yeah, if you want to refer back to one of the earlier webinars for that one, no, go on, John.
Yeah, we can send out the links to that. So yeah, we've got a whole webinar related to asset health scores. Yeah, I mean, it's one of the things that we were Chris and I were chatting about before in terms of what we might want to do for future webinars, because we've done one broadly on asset health and risk, and we had so much content when we were doing it that I think I started off with about 200 slides, and I'm like, how am I going to make this into the 30 slides that I need for a 40-minute presentation? So it's quite a big subject, that. So there is a webinar on it. You're welcome to go back to that one, but that could be a suggestion for another webinar as well. Maybe we'll do a bit of a deeper dive of asset health scores.
Great question. Thanks for that, Vadim. Next one, Jacobo, will the videos be available? Yes, they will be. We'll share a link, and for any that's interested, if you'd like any of the earlier session recordings, please do shout up, and we'll be able to share them as well. Yeah, so that's the questions in the chat. If anyone would like to raise any further questions, either in the chat or feel free to unmute yourselves and fire away.
I just have one question. On the defining asset failures, you mentioned electrical, mechanical, and operational, something like that, right?
Yeah.
I think one of them is very predominant, which is, I think, was not there, is the thermal, which is more associated to the temperature.
Okay.
So I'm not sure if you were trying to include that in the environment, but I think itself it's a separate mode of failure, which is quite predominant in the assets installed in the field and at sites. So probably should be considered.
Yeah, I sort of agree. I think it's not an exhaustive list, but I think yes, and I think it depends on how you want to treat those, whether you would treat those as a separate failure mode or include those within one of the other failure modes. But you're right, yes.
Thanks for the question. Another one that's just popped into the chat. Yes, so a question about whether an email will be sent out for the videos. Yes, please do get in touch. We'll be sharing the slides after the session. Please do reach out to us if you'd like a link to the videos or the recordings either of this session or the previous. Please do get in touch. We'll share those with you, no problem.
You'll send the presentation out as a matter of course anyway.
Yes, absolutely. Yeah, absolutely. Yeah. So you'll have my contact details. I'll send out the slide deck after this session. So feel free to get in touch if there's any further questions or indeed for a link to the previous videos.
It's all quiet at the minute, so I'll just move on to the next slide. So feel free if you think of any questions in the meantime. So our next webinar is about asset data, so asset model data requirements. So that's on the 26th of April. So feel free to register for that one if you haven't done so. And then after that, we were sort of debating, like I say, about what we were going to do next. So if you've got any suggestions in terms of topics you'd like to see on the general subject of asset health, risk and interventions and things, then do get in touch with us. If not, then we've got a LinkedIn poll that we're going to put out shortly, and that will have some options in there as well, so look out for that. And then I'll just move on to the final slide. So just for information in terms of what we do. So if you do need any help and assistance with asset health modelling or consultancy and things, this is really, the area that we work in. So we've helped lots of organisations over the world, and lots of organisations move from sort of whatever their current state is to a highly mature sort of asset health state. So we've got solutions and software and things like that can help you do that. And I apologise for the slightly blatant sales pitch there, but that's what we do. It's kind of our bread and butter, if you like. But I put that one slide in so you can have a look through that. And if you've got any questions or anything of interest there, then do give us a shout.
It doesn't look as if there's been any further questions come through on the chat. So if there isn't any due, just leaves me to say thank you very much for joining the session. We do appreciate it. Please do reach out to us if you have any further questions or would like any further information. And just many thanks for Joanne for a very informative session. Thank you.
No problem. Thanks everybody for joining, and hope to see you in the future.
Thanks all. Take care.
Thanks. Bye now.